If we want to complete the square on x squared plus 10x, we do what we do whenever we complete the square. We take, we first note that the coefficient of x squared is 1, so coefficient here is 1, so we take the square of half the coefficient of 10, the coefficient of x, which is 10. So half of 10 is 5, so we add 5 squared. We get x squared plus 10x plus 25. It's a perfect square. It's the square of x plus 5. Now, if we want to get an equivalent expression, x squared plus 10x equals x squared plus 10x. Sure. Now, if we add 25, this is no longer equal to this. But if we then subtract 25, well, 25 minus 25 is 0, so clearly this is equal to this. This then equals x plus 5 quantity squared minus 25. So this is an equivalent expression. So I'll say that this and this are equivalent expressions. One application of completing the square, if we have the function y equals f of x equals x squared plus 10x, well, we complete the square, and that tells us ultimately that this is equal to x plus 5 squared minus 25. This is a y equals x squared with a horizontal shift of minus 5, vertical shift negative 25. Another application, if we want to solve this equation, we replace x squared plus 10x with x squared plus 10x plus 25 minus 25, and we get this. We put parentheses around this just to indicate what we're doing, and we have then x plus 5 quantity squared. Negative 25 and 14 is negative 11. Put that on the other side, it's 11, so that we get x plus 5 equals plus or minus 11, which implies x equals 5 plus square root of 11, square root of 11, or x equals 5 minus the square root of 11. We can complete the square symbolically on ax squared plus bx plus c equals 0, the general equation of a quadratic. Divide through by a, so we have a unit coefficient of 1 in front of x squared, and then we add and subtract half the coefficient of x, just as we've done up here, and that coefficient would be b over a. Half that coefficient would be b over 2a. We square that, we're going to get b squared over 4a squared. We add and subtract that, group it, etc. Same thing we did up here, and we get the quadratic formula.